Hello. I'm going to try and explain to you how or some of the things that I did to develop this tailstock, new tailstock for the Taig lathe. Please excuse me, I'm not a professional at this kind of thing, so it won't be very exciting, I'm sure. Okay, the Taig lathe has a tailstock that is somewhat to be desired, and so I decided that after seeing some photographs of Mr. David Urich's Metal Master machine, I decided that perhaps I could do something of the same thing on the Taig. And so after looking at it for a while, I realised that at the back of the Taig bed in the aluminium extrusion there is a dovetail, a shallow dovetail, which could be used to support an accessory of some kind. And so I came up with this idea where I would almost copy the idea of Mr. Urich's tailstock on his Metal Master lathe, and so that was the beginning. The first thing that I did was to make two blocks that would fit into the dovetails at the back of the lathe bed, and in turn I would have two columns coming up from these blocks, and I put them at an angle of 15 degrees away from the lathe bed, because if I ever use the 1-inch spacer blocks for a larger swing, then the uprights wouldn't interfere with the chuck or the part that's in the chuck. So anyway, I made the blocks and the dovetails and drilled the holes and bored the holes in the blocks for the 5/8 diameter pillars at both ends. Then I also have the Taig mill, so I placed another piece of 5/8 bar on the mill along the x-axis in V blocks, and I milled actually I bored two scallops out from each end of the rod, the 5/8 rod, to fit the radius of the two uprights, the 5/8 diameter uprights. So from there I had to decide how I was going to assemble the tailstock and what I required. And so I thought, well, I don't want this tailstock to interfere with anything that I'm doing on the lathe when I'm not needing it. So I decided that I would make the tailstock in two parts, and one is the main block that slides on the horizontal 5/8 bar, which is, you can't see it here, but oh, I'm going to have to stop because I've left something out, but I'll just carry on for now. So I have this block that slides, and I thought, well, to keep it in position all the way along level with the bed, that I would use a square key. And so I inserted a square key in the length of the horizontal guide bar, and made a corresponding bush to fit inside the block, so that they made contact with one another, and that kept the block level. But there was a slight bit of slack in the key. Not an easy thing to do, to get it exactly accurate within, say, half a thou or even less. So anyway, I didn't notice that until after I'd completed the unit. So anyway, I put the square key in and made the block and put dovetails on the block so that this the main block, which is here, I put dovetails, as you can see, on a large aluminium block, and shaped the block afterwards, but I've screwed and doweled the two strips to give me the dovetails, the female dovetail, because it was too difficult to do all in one piece. So I did that, and it assembled beautifully. There's not much play in the dovetail, and it slides on and off fairly easy, but not with too much slack. So that was fine. So then I carried on and started making other parts for the block, and I had to do lots of measurements and checking of measurements, and so I did some rough sketches on AutoCAD. Not being a professional again, the drawings are much to be desired probably when looked at by a professional, but they were good enough to give me the information that I required. So then I decided, well, I want to go with a 1 Morse taper, because in my previous lathe it was a Drummond M type, and that had 1 Morse taper, and so I had quite a few items that had 1 Morse taper on them. So that's what I did. Now what I did there, here's the shaft, and it's cast iron, and what I did was I ordered in what they call a straight sleeve 1 Morse taper. It's like a repair sleeve for a drill press, and it has the 1 Morse taper in the end, and it's 1.25 inches outside diameter, and it's parallel all the way along. So I used a 1 Morse taper plug with centers in it, and I started machining the 1 Morse taper sleeve down to a smaller diameter, and I did that all between centers, so it's pretty good. I then bored out the cast iron sleeve, tailstock sleeve, and I bored it out on the Drummond, which I still had at that time, and then the 1 Morse taper sleeve that I machined down, it inserted it into the end of the bar, and Loctited it in. So that is the beginning. That's how I got the 1 Morse taper. I wasn't too keen on trying to bore out a 1 Morse taper and trying to get the right angle and fit in and blew in and fit in and blew in and moving a little bit more. So that's what I did there, and it's worked out very, very well. Now on this shaft I have a 1/8 groove that travels from this point here just before breakout right the way to the back of the sleeve, cast iron sleeve, and that engages with a key that is on this steel insert here. It's just a small 1/8, I think it is. And anyway, I machined a little keyway on it, all in one, and then milled out the aperture and set it in there, and that engages with the slot in the quill, and if I turn it round a little bit, you'll see here I have a rack. Now that rack was originally on the saddle. It actually moved the saddle along the bed, and that's original from Taig. The hand wheel engaged with it, and since putting the power feed on the saddle on the lathe, I don't need this anymore. So I removed that and used that for this purpose of a rack and pinion that I turn, which moves the quill in and out of the unit. What have we got on the other side here? Got that and that. Yes, I put the slot in there to correspond with the bought one more taper sleeve, so that if at any time I did have a problem, I've always got a second way to release anything that gets locked in there. In the meantime, I drilled through from this end and threaded, and I've got I think it's 532 pin that goes into the end for ejection, and then I have a screw here that pushes the pin forward and ejects the Morse taper. I also at the beginning I made up a split clamping sleeve which sits around, where are we? It sits around the quill, and when you just give it a nip, it actually locks the quill into the housing and stops it from moving backwards and forwards. Now that was the original design that I had. So I had the rack and the split clamp and the whole unit riding on the square